Hey, hello everyone. So I just recently came across a channel on YouTube, which is named Hold My Bipolar Watch This. So for the rest of the video, I'll just refer to him as Bipolar for short. And he has an amazing channel. Like, I'm in love with this person's channel. After you watch this video, be sure to check that person out. He's doing an amazing job. So I came across a video of his in which he was solving this question from Problems in General Physics by IRODOV. And so, like, when he had started the video, I paused his video and I thought, let me first try the problem myself, and then I'll see how he proceeds to solve it. So I solved the problem and I got the correct answer, and then I watched his video and I was amazed because he actually used a different method. And yeah, it was a pretty clever method. But right now in this video, I'm going to share the method which I used to solve that problem. Now, I ain't saying that his method is bad or my method is better or something. This is just a different approach to how you can also solve this question. So, if Bipolar, if you're watching this, I love your channel, bro. Keep up the good work. Okay, so it is given that a ball starts falling with zero initial velocity on a smooth inclined plane, forming an angle alpha with the horizontal. So we have an inclined plane with us. I don't have a camera setup like his. He has a very good camera setup, but I don't have a good camera and stuff, so I'm just using my tablet to record. But well, never mind. So we've got an inclined plane and it makes an angle alpha with the horizontal, so this is the horizontal direction. Having fallen a distance h, the ball rebounds elastically. So first of all, the ball is in the air and it is at a height of h from the inclined plane. Now what happens is that this ball drops and it rebounds elastically. Now rebounding elastically, it means that it maintains its angle of incidence. So the angle with which it hits the inclined plane is same as the angle with which it leaves the inclined plane. So there we go. And also the velocity with which it hits the inclined plane is same as the velocity with which it leaves the inclined plane. So this is kind of the trajectory that the ball will travel. So let's make a normal here. So this normal makes an angle of 90 degrees with our plane of the inclined plane. What just happened? Okay. So how I thought about this problem is to transform our coordinate axis in this form. So usually when we're working with coordinate axis, x and y axis, we are talking about this kind of representation. But I thought that because everything's taking place in an inclined manner, so like everything's inclined, so why not I just take my axis incline at an angle of alpha with the horizontal. So from now on, our axis is actually this. So this is y, this is minus y, this is x, and this is minus x. And this makes an angle of alpha with the horizontal. Now, the ball attains some velocity while it's falling. Let's call that velocity v, and we can calculate v later. First of all, I need to calculate this angle. I'm going to apply simple rules of projectile motion. So I'm going to calculate this angle here. So let me just calculate it. We've got this angle as alpha here. What I'm going to do is drop down a normal. Not a normal. I'm going to extend the line of the ball falling. And so from here, I get this angle to be equal to 90 minus alpha. This angle. And if you notice, this angle right here, it is a vertically opposite angle to this 90 minus alpha. So this angle should also be 90 minus alpha. Now, as I said, this is the normal. This line and let me just mark it with a different color. This line and this line, they are at 90 degrees to each other. Alright? So, if this is 90 minus alpha, then this should be alpha, because these two angles together should make 90 degrees. And now they are. Now, you see, because this is an elastic collision, so the angle of incidence of the ball, which is this angle, should be equal to this angle, which is the angle of reflection. So this angle should also be alpha, because this is an elastic collision. Now again, this is the normal, and this is our plane, and these two make 90 degrees with each other. So if this angle is alpha, then this angle 90 minus alpha. I'm sorry for the weird cuts. I should just... Yeah, so just enable do not disturb. Yeah, I'm sorry. Okay. Notifications are, I don't know, they're annoying. Okay, so this angle we found out to be 90 minus alpha. Now let's call this 90 minus alpha to be beta. Okay? And now I'm just applying basic rules of projectile motion. Now this ball arrives at the inclined plane at a velocity of v, so it leaves also at a velocity of v, because this is an elastic collision, so the velocity remains the same. Now I can write components of the velocity and the acceleration. Now notice how the ball experiences a downward acceleration of g, which is the acceleration due to the gravity. But as I told you, now our coordinate axis is something like this. So this downward direction of the acceleration due to gravity won't support our choice of axis. So what we have to do is break this g into its components. So this is the direction of g right here, and our axis made an angle of alpha. Why don't I make this a bit bigger? A bit... yeah, like that. So it's a bit bigger now. Cool. So it makes an angle of alpha with the horizontal. Now, you see, this angle is 90 minus alpha, because this is a right angle triangle, this thing. So because of that, this angle should also be alpha. Now you see that we've got a component of g in this direction, which is g times cos of alpha, because this is the hypotenuse and this is the base. So g cos of alpha is this, and this component here, this is g sine alpha. Now you see, this is our x direction and this is our minus y direction. So our acceleration in the x-axis should be g sine alpha, and our acceleration in the y direction should be g cos alpha multiplied by minus 1, because it's towards the negative y direction. So we can just write it as minus g times cos of alpha. Right? And now I'm going to break this velocity into the components according to our coordinate axis. So it's actually easy from here. Let's call this beta, because our 90 minus alpha was beta. From here, we can see that the component of the velocity along this direction is v cos beta, and along this direction, it is v sine beta. Right? So let's write those things down. So v in the x direction is, let's call this v, oh no, vx is fine. So is equal to v cos of beta, not alpha, cos of beta. And in the y direction, it is v sine of beta. Right? And now you see that when the ball hits the inclined plane, let me choose another color, red. Yes, okay. When the ball hits the inclined plane at this position and at this position, the question is asking us, the ball rebounds elastically off the inclined plane. At what distance from the impact point will the ball rebound for the second time? So it's actually asking us this distance. Now, when the ball hits the inclined plane, you see that its y coordinate is 0, according to our choice of coordinate axis. So here it is 0, and then it travels this, and then it hits here. Notice how this and this position in the y direction is the same. These both positions are at y is equal to 0 according to our coordinate axis. So let me find how much time it takes to travel from here again to y0. So I'm just going to use sy is equal to vy times t plus half ay t squared. This is just an equation of motion. Now, this sy is the coordinate in the y-axis. I want this to be 0. And vy, we have the value v sine beta times t plus half. Ay is minus g cos alpha, so let's just replace the plus with the minus. G cos of alpha times t squared. Notice how I can factor out a t out of this expression. So it leaves me with v sine beta minus t by 2 g cos alpha. Now, because this was a quadratic in t, I would get two solutions. So one solution I'm getting is t equal to 0, and one solution is this expression equal to 0. Now, t is equal to 0 is actually a very intuitive solution if you think about it. At t is equal to 0, t is equal to 0 is that point when the ball is being rebounded from the inclined plane. So, when the ball is being rebounded, it is at y is equal to 0. So, this math is actually correct. But we already know that point, right? So, we need to solve this equation to get the other point. So v sine beta minus t by 2 times g cos of alpha equals 0. Now, our beta was 90 minus alpha. So I can just write it as v sine of 90 minus alpha minus t by 2 times g cos of alpha equal to 0. Now, we know the sine of 90 minus theta is equal to cos of theta. This is a trigonometric property. So this will be equal to cos of alpha minus t by 2g cos of alpha. I can just cancel out cos of alpha because it is non-zero. I get v minus gt by 2 equal to 0. V is equal to gt by 2. And I want a value of t, so I wanted the time in which it rebounds again with the inclined plane, so I can calculate how much the ball travels in the x direction during that time. So our time comes out to be 2v by g. And if you analyze it dimensionally, it comes out to be dimensionally correct. The dimensions of velocity is meter per second, and dimensions of g is meter per second squared. So these two cancel out, and we are left with seconds. So which is actually the unit of t. So there we go, the value of t. And now we just need to find out how much the ball has traveled during this time period in the x direction. So we just need to apply this same equation again, but now in the x direction. So sx, now sx in this case is not known to us. In the previous case, sy was known because the ball just rebounds back, so it should be 0. But right now, we want to calculate the value of sx. So this would be vx times t plus half ax times t squared. We need to find out sx, and we know that vx is equal to v times cos of beta. So v times cos of beta is just sine of alpha according to trigonometric identities I just mentioned here, times t. Now we put the value of t here. 2vg plus half times ax was g sine alpha times t squared, which is 4v squared by g squared. Simplifying everything up, we get 2v squared sine alpha by g plus 2v squared sine alpha by g. Cool. We get the same expression. So we just add up everything up. We get 4v squared sine alpha by g. Now notice how we don't know the value of v yet, so we can just easily calculate it. We know that the ball is falling from a height of h, right? And we need to calculate the velocity at this point. And the velocity at this point is 0 because it's a free fall. So we just need to conserve energy here. So the kinetic energy at this point should be equal to the potential energy at this point. So mgh is equal to half times mv squared. Cancel out the m's. We don't even know the value of mass of the ball, but we just calculated that v squared should be equal to 2gh. And substituting v squared is equal to 2gh in this equation gives us 4 times 2gh times sine of alpha divided by g. Canceling everything, we get 8h sine alpha as the distance, as this distance. And this is actually the correct answer. So yeah, tell me if you guys like these kind of videos. And bipolar, if you're watching this, I love your channel. See ya.